Good afternoon everyone, I am Devika from 𝚱𝚡𝚝 final year. Our batchmates are 𝚱𝚊𝚝𝚝 and 𝚘𝚡𝚗𝚘𝚡. With the help of our guide, Mrs. Y. Mastanamma, we have decided to choose a project title naming EV battery management system with charge monitor and fire detection. The motivation behind developing an electrical battery management system is to monitor and manage the battery, ensuring that it is operated within safe limits and that it provides optimal performance, and to improve reliability during charging and discharging process. So in this video, we try to explain the overall concept of battery management system, which includes introduction, importance and applications of BMS, components required, working operation. Before that, we should know about the basic points of electric vehicle and why BMS is needed for electric vehicles. Electric vehicle technology plays an important role in greenhouse gas limitation and carbon pollutions. Rechargeable batteries are used to deliver power to auxiliary systems and monitor in the electric vehicle applications. Among all rechargeable batteries, lithium-ion batteries will give higher efficiency for electric mobility because lithium batteries have low self-discharge rate, wide operating range, maximum energy density, and high life cycle. But since few days, people found that EV catches fire, which leads to fire explosion. Many people lost their life because of fire accidents due to fire explosion of EV. A city electric bus caught fire while charging in Telangana. Nearly 8 people killed and several people injured after e-bike showroom blast in Secunderabad. After many consequences, people found that the two main reasons of EV fire accidents are overcharging or overheating of the battery and the use of low quality components in the manufacture of lithium-ion batteries. So, to overcome all these problems, battery management system is used to protect the battery pack in electric vehicle to ensure safe and secure life with better performance. Now let's see the components which is required for battery management system and the connections made on PCB. This is a 3S lithium-ion battery, which 3 batteries are connected in series. Each cell is of 3.7 volts, 96 watt hour and 800 milliampere hour. Next is a voltage sensor with input voltage is 0 to 25 volts. Voltage detection range is 0.02 to 25. This is the analog voltage with dimensions 4 into 3 into 2 centimeters. That is used to measure the voltage up to 25 volts using the 5 volt analog pin of any microcontroller. We are using ACS 712 current sensor, which is fully integrated half effect based linear current sensor with 2.1 kV RMS voltage isolation, a temperature and humidity sensor with a temperature range 0 to 50 degrees Celsius, operating voltage is 3.5 volts to 5.5 volts, operating current is 0.3 milliamperes. A 16 into 4 LCD display with 16 characters and 4 rows, which shows the 4 parameter values like voltage, current, temperature and the state of charge of a battery. And some of the electronic devices like transistors, diodes, capacitors, resistors, crystal oscillator are used to balance the parameter values with a better performance of a battery. And this is the STM32 microcontroller, offer a large number of serial and parallel connection peripherals which can be interfaced with all kinds of electronic components including sensor, displays, cameras, motors, etc. And the DC motor is used for power consumption during discharging process. Let's start the working operation. When the supply is given, the charging process takes place by choosing the charging option using the push buttons connected to B12, B13, B14 and B15 pins of STM32 microcontroller. During the charging process, the voltage increases constantly, which is represented on LCD display and LED glows. When the battery is fully charged, the voltage cutoff as the voltage exceeds beyond 12 volts is detected by voltage sensor and LED goes off. All the variations of parameters like current, voltage and temperature and SOC are monitored and controlled by sensors, which is shown on 16:4 LCD display. Similarly, for discharging process, the voltage is going to decrease. Here the load with 12 volts voltage capacity is used for power consumption. And also the temperature gradually increases when the energy is consumed, so-called discharging. As the battery heating during discharging process is a time-taking process, we are using fire to show fire detection operation. And if the temperature increases beyond the limit value, that is 50 degrees Celsius, the buzzer sounds, which is used for the fire or heat indication. Here the THT11 module is used to sense the temperature. Through this operation, the parameter values are monitored and controlled, which incorporate the proper charging method for the appropriate battery type and overcharge protection by estimating an accurate SOC to prevent battery damage.